Welcome to Spring LIB.
All right, we've got the following alkyne, and we're reacting it with water, sulfuric acid, and mercuric sulfate. Right. So if you take an alkyne and you react it with those reagents, what you're doing is turning it into an alkene with an OH attached. Right. Now recall that this is known as an enol, and that it will tautomerize, or just sort of naturally turn into, an aldehyde in this case. Either turn into an aldehyde or a ketone, depending. And so the exact same thing will happen with our alkyne. Let me make a note of the carbons here. This is carbon 1 in red, and we'll call this carbon 2 in blue. Now we'll redraw this as an alkene with an OH on one side. Okay, carbon 2 in blue, carbon 1 in red, with an OH on one side, specifically the side that is less substituted, right? And then we'll consider that the same thing can happen with an OH on the blue carbon, right, which would look like so. Great. And what we see then is that 1 is represented by this molecule, or answer 1 is represented by the second molecule, and that 2 is represented by option 2. Okay. So then, yeah, we basically got two options. Does the OH go to the internal carbon, or does it go to the terminal carbon? And in the case specifically where we're adding H2O and sulfuric acid and mercuric sulfate, we always get the OH goes to the internal, or in this case, the blue carbon and not the red. If we were to do hydroboration oxidation, that's how we would end up putting an OH on the red carbon. So in this particular case, we get the answer is 1. And it's not shown here, but this would tautomerize into something that follows that sort of ketone right there.